Your blood right now contains a protein your muscles manufactured during the last time you were genuinely breathless. Not winded, not warm, breathless. The specific state where your lungs become the limiting factor, where speech fragments, where your body crosses a metabolic threshold that your morning walk has never reached. That protein is called Brain-Derived Neurotrophic Factor. It crosses your blood-brain barrier within 4 minutes of the gear shift that produced it. Inside your hippocampus, the brain structure Alzheimer's disease attacks first. The structure most directly responsible for the memory consolidation that builds cognitive reserve across a lifetime. It initiates neurogenesis. New neurons, not metaphorically, not activation of existing circuits, structural growth of new neural tissue in a brain that your biology textbook told you had stopped growing decades ago. Your 30-minute morning walk produces some of this protein. The 90 seconds you spent running for a bus last Tuesday produced categorically more, not proportionally more, categorically more. A different quantity produced by a different physiological state, triggered by a different biological threshold that your walk, however consistent, however dedicated, has never crossed. This is not a story about exercise. It is a story about a measurement error that persisted for 30 years, about an instrument that could not see the thing that mattered most, about the people who followed the guidelines precisely and completely, and what the guidelines could not tell them. And it is a story about 3.5 minutes. For 3 decades, exercise science built its understanding of physical activity and health on a single instrument, the questionnaire. You have filled one out, the kind handed to you at a doctor's office or mailed to your home as part of a population health survey. How many minutes of moderate exercise did you do last week? How many minutes of vigorous exercise? Think about how you answered. Think about the 90 seconds you sprinted across a rain-soaked car park on Tuesday. Think about the 2 minutes of playing chase with your grandchild that left you briefly unable to speak. Think about climbing 3 flights of stairs quickly because the lift was occupied and you were running late. Think about the single hill you climbed fast on your walk home, the 60 seconds where your breathing became audible. None of that was in your answer, because none of it was memorable enough to count. It was not scheduled. It was not sustained. It did not feel like exercise. It felt like Tuesday. And none of it was in the original studies either. The questionnaire has a fundamental structural flaw that no improvement in its design can correct. It captures deliberate, sustained, memorable activity. The 30-minute walk you scheduled, the gym session you planned. These are the activities that enter conscious recall because they were initiated by intention, sustained long enough to register as events, and completed with a sense of having exercised. The 90-second sprint, the 2-minute chase, the fast stair climb between floors. These are invisible to memory not because they were insignificant, but because they were spontaneous, brief, and absorbed into the ordinary fabric of a moving day. The instrument that built your exercise guidelines for 30 years systematically could not see them. Worse, it could not measure intensity at all. A questionnaire cannot distinguish a brisk walk from a jog. It cannot measure the difference between climbing stairs leisurely and climbing them at genuine effort. It captures categories, light, moderate, vigorous, as self-reported labels applied by memory to activities that the person filing the form may have genuinely misclassified. Not from dishonesty, but because the subjective experience of intensity is unreliable. One person's brisk is another person's stroll. The instrument could not resolve the difference. The 2-to-1 ratio, the ratio encoded into every exercise guideline issued for the last 30 years. The ratio that told you 150 minutes of moderate activity is equivalent to 75 minutes of vigorous. That validated your daily walk as a complete exercise prescription was not calculated from who developed cancer and who did not. It was not derived from cardiovascular death rates. It was not drawn from longitudinal mortality data tracking who survived into their 80s and who did not. It was calculated from calorie expenditure. The scientists were answering a different question entirely. How much energy does this use? The answer to that question became the foundation of your exercise prescription. Calorie math, dressed as mortality science, encoded into guidelines that told 150 million daily walkers they had covered their exercise needs. The instrument failed. The guidelines it produced failed with it. The instrument changed. In the last decade, researchers began strapping accelerometers, devices recording actual movement, actual intensity, continuously, in real time, to large populations, and tracking what happened to them across years. Deaths from all causes, cardiovascular deaths, cancer deaths, diabetes onset, stroke. For the first time in the history of exercise science, the relationship between physical activity and mortality was measured directly, not recalled, not estimated from calorie calculations, not inferred from questionnaire responses filtered through the unreliable aperture of human memory. And for the first time in 30 years, every brief, vigorous burst that the questionnaire had made invisible suddenly appeared in the data. The 90-second sprint, the fast stair climb, the 2 minutes of playing chase, the single hard hill. These had been happening all along in the bodies of people who showed up in mortality data as mysteriously healthier than their questionnaire responses predicted. The accelerometer explained why. It captured something the questionnaire had never even tried to capture. The biological threshold crossing, the moment when moderate becomes vigorous. The gear shift that the questionnaire could not measure because it was asking for recollection, not recording reality. The accelerometer is a speed camera. The questionnaire was asking you how fast you drove last Tuesday. When the speed camera data was analyzed against the mortality outcomes, the 2-to-1 ratio did not merely require revision. It collapsed. Hold the 2-to-1 in your mind. 1 minute of vigorous exercise equals 2 minutes of moderate. That is what 30 years of guidelines encoded. That is what your walk was validated against. Here is what the accelerometer found. For all-cause mortality, dying from anything, at any age, from any cause, 1 minute of vigorous activity equals 4 minutes of moderate activity. Not 2-to-1, 4-to-1. The guidelines were wrong by a factor of 2 for the broadest mortality outcome we can measure. For cardiovascular death, the outcome that will statistically determine whether you see your 80th birthday, 1 minute of vigorous activity equals 8 minutes of moderate activity. Not 2-to-1, 8-to-1. For the leading cause of death in the developed world, the guideline ratio was wrong by a factor of 4. For type 2 diabetes risk, a condition now affecting 1 in 10 adults globally, a condition that is itself a leading driver of cardiovascular disease, kidney failure, and limb amputation. 1 minute of vigorous activity equals 10 minutes of moderate activity, 10-to-1. And then the cancer number. For cancer death, across cancer types, in populations tracked by accelerometer measured activity, brief vigorous activity provided a magnitude of protection that the questionnaire had made entirely invisible for 3 decades. In women specifically, accumulating just 3.5 minutes of vigorous activity per day, not in a gym, not in a structured workout, not sustained, simply accumulated across the day in whatever fragmented, spontaneous form it arrived, reduced cancer risk by 40%. 40%. From 3.5 minutes per day that the questionnaire could not count, that the guidelines could not see, that your morning walk was not delivering, no drug in a cancer prevention clinical trial has produced a 40% risk reduction without significant side effects and cost. This number did not emerge from a pharmaceutical laboratory. It came from the moments the questionnaire had been discarding for 30 years. The brief gear shifts woven through ordinary life that added up to something the science could only quantify once the instrument changed. There are 3 distinct operating modes your body uses, and they are not points on a single line. Light activity is the locomotion of daily life, moving between rooms, walking at a comfortable pace, standing. Your heart rate barely shifts. Your slow-twitch type 1 muscle fibers handle the load efficiently. Your breathing is unchanged. Moderate intensity is walking with intent, a brisk, purposeful stride, enough elevation and breathing to register, but still controlled, conversational, sustainable for hours. Your slow twitch fibers are working. A fraction of your intermediate fibers are recruited. Cardiovascular demand increases measurably. Vigorous intensity is a different operating mode. Jogging, cycling hard, swimming at pace, climbing stairs fast, playing chase until you are genuinely breathless. The distinguishing feature is not effort or discomfort. It is respiratory limitation. Your lungs become the constraint. Not your legs, not your willpower, your lungs. When your body crosses this threshold, a cascade activates that moderate intensity cannot produce, regardless of duration. Your type 2 fast twitch muscle fibers recruit, the high force, high power fibers that your 30-minute walk has never called upon. These fibers are the primary site of BDNF production in skeletal muscle. They are also the fibers most sensitive to the metabolic signaling that drives insulin sensitivity, that activates the immune surveillance pathways connected to cancer protection, that triggers the mitochondrial biogenesis that slows cellular aging. Your walk does not recruit them. The gear shift does. Simultaneously, lactate, produced when your muscles operate beyond aerobic capacity, crosses your blood-brain barrier and directly stimulates hippocampal BDNF production through a pathway entirely separate from the muscular production route. Two independent delivery mechanisms for the same growth signal, both activated by the same threshold crossing. Neither activates during moderate intensity, sustained indefinitely. Your sympathetic nervous system releases a surge of catecholamines, epinephrine and norepinephrine, that mobilize free fatty acids from adipose tissue, spike peripheral immune cell mobilization, and trigger the natural killer cell deployment that represents your body's most direct form of cancer immunosurveillance. These natural killer cells patrol for precancerous cells, cells that have undergone malignant transformation but have not yet formed detectable tumors, with an efficiency that increases measurably during and after vigorous activity. Interleukin-6, released from contracting muscle during intense exercise, acts as a myokine, a muscle hormone, that crosses into the systemic circulation and signals anti-inflammatory pathways in organs far from the muscle that produced it. Chronic low-grade inflammation is a driver of cancer initiation and progression. The myokine signal from intense muscular work is one of the mechanisms connecting brief vigorous activity to cancer outcomes at the cellular level. Your heat shock proteins surge. Your antioxidant enzyme systems upregulate. Superoxide dismutase, catalase, glutathione peroxidase, the endogenous antioxidant machinery that protects DNA from oxidative damage, is induced by the very oxidative stress that intense exercise briefly creates, a paradox that the biology resolves. The stress that your intense effort produces is the signal that tells your DNA repair machinery to strengthen. The mild damage triggers the protective adaptation. None of this happens during your walk. Your walk is real movement. It is better than stillness. It produces health outcomes that inactivity cannot. But it is a different gear entirely, and the biological adaptations triggered by the vigorous threshold have no low-intensity equivalent. No amount of moderate activity duration that substitutes for the threshold crossing. The 8-to-1 cardiovascular ratio does not mean your walk is 8 times less efficient. It means that for cardiovascular protection specifically, 8 minutes of walking produces what 1 minute of vigorous activity produces, not approximately, measured directly in who died and who did not. For 30 years, 2 people filled in the same questionnaire. Person A walked briskly for 30 minutes every morning, 5 days a week. Consistent, dedicated, precisely following the guideline. Their questionnaire, 150 minutes of moderate activity per week. Person B walked the same route most days, but added moments. Sprinted for 90 seconds when running late. Took the stairs fast. Jogged briefly when a bus appeared. Played chase with their dog until breathless. Their questionnaire: approximately 150 minutes of moderate activity per week. The questionnaire could not see the difference. Both forms returned the same answer. Both people entered the database as equivalent exercisers. The mortality data over the next decade showed them as different. Person B was living with brief, vigorous bursts woven through ordinary days, not scheduled, not sustained, not perceived as exercise, not counted. The accelerometer would have captured every one of those bursts. The questionnaire discarded all of them. The people who moved in short, intense bursts through daily life had been appearing in mortality data as healthier than their reported exercise predicted. For 30 years, researchers noted this as unexplained variance, statistical noise in the models, attributed to measurement error, confounding variables, the ordinary imprecision of population health research. The accelerometer eliminated the noise. What was variance became signal. What was unexplained became the most important finding the field had produced in a generation. The people who looked mysteriously healthy had not been mysterious at all. They had been moving in a gear the instrument could not see. The clarity you feel after something physically hard, the mental sharpness, the focus that arrives without caffeine, the world slightly more legible than before you started, is not a mood. It is not the subjective relief of exercise completion. It is BDNF, crossing your blood-brain barrier, measurable in cerebrospinal fluid within 4 minutes of the gear shift. Quantifiable, real. A molecular explanation for a subjective experience so universal that every culture that has ever existed has recognized the link between physical intensity and mental clarity, without knowing the name of the protein responsible. BDNF binds to TrkB receptors in your hippocampal dentate gyrus, the subregion of the hippocampus where neurogenesis occurs in adult brains. The binding activates ERK and PI3K signaling cascades that promote neural progenitor cell differentiation and survival. New neurons are born. Not figuratively, the process is measurable through BRDU labeling in animal models and inferred through volumetric MRI in humans. John Rady at Harvard Medical School spent a decade assembling the neuroscience. Kirk Erickson at the University of Pittsburgh published the human MRI evidence. The hippocampus grows physically in response to vigorous aerobic exercise in older adults. Not maintains its volume, not slows its shrinkage, grows. The hippocampus is the first structure Alzheimer's disease attacks. It is the structure where BDNF exerts its most powerful neuroprotective effects. It is the structure whose volume correlates most directly with the cognitive reserve that determines whether a person in their 70s notices the early losses of neurodegeneration, or has built sufficient redundancy to compensate for them without symptoms. Every time you choose the comfortable pace, your hippocampus does not receive the molecular signal that tells it to grow. Your cardiovascular system is not the only system living below the threshold. The most structurally compelling evidence for what intense cognitive and physical demand does to human brain tissue came not from a controlled trial, but from the streets of London. To earn a black cab license in London, a driver must pass an examination called the Knowledge. The candidate must memorize 25,000 streets within a 6-mile radius of Charing Cross Station. Every road, every one-way restriction, every landmark, every route between any 2 points in one of the most complex urban environments on Earth, recalled on demand, without GPS, without maps, under examination conditions. Average preparation time, 3 to 4 years of daily intensive study. Candidates drive the routes on mopeds, committing the spatial relationships to memory through a repeated physical traversal combined with map study. The cognitive demand is not incidental. It is total. Eleanor Maguire at University College London began scanning the brains of these drivers in the late 1990s. Her expectation was heightened activation in memory regions during spatial tasks. The methodology was functional MRI, recording neural activity during navigation challenges. What she found was structural. The hippocampi of London taxi drivers were physically larger than those of matched non-drivers. not more active during navigation, larger in their resting MRI anatomy. The memory center of the brain had grown, measurably, visibly, quantifiably on structural imaging, in response to years of intensive spatial demand. She followed drivers longitudinally. When they retired and stopped navigating, their hippocampal volumes began returning toward baseline. The structure was not permanent. It was responsive, built by demand, maintained by demand, contracted by its absence. The same responsiveness that McGuire documented through years of intensive spatial learning is what vigorous exercise produces through BDNF delivery in minutes. Different stimulus, same responsive tissue, same mechanism of growth through demand. Your hippocampus is not a fixed structure slowly deteriorating on a genetically programmed timeline. It is a responsive organ waiting for the signal that tells it to grow. The signal has a delivery mechanism your body has been building since birth. The delivery mechanism is the gear shift. Consider what the cardiovascular medicine system has assembled to approach what vigorous exercise provides to your heart. Daily statin therapy, requiring liver enzyme monitoring every 6 months, managing the myopathy risk that affects between 5 and 10% of users, harrying the cognitive side effect profile that remains actively debated in the cardiology literature. ACE inhibitors or beta blockers requiring ongoing blood pressure surveillance and kidney function testing to manage their renal effects. Echocardiography requiring specialist equipment, trained sonographers, and cardiologist interpretation. Annual cost per patient, between $2,000 and $8,000 depending on location and insurance status. The effect of this system on cardiac aging, management, slowing of progression, risk reduction through secondary prevention, not reversal. Benjamin Levine at the Institute for Exercise and Environmental Medicine published evidence that people who exercised 5 hours per week, including high-intensity interval training, showed measurable reversal of cardiac aging by approximately 20 years. The left ventricle demonstrated structural improvement, ventricular compliance, the ability of the heart to fill efficiently, the property most lost with sedentary aging, was restored toward the values of adults 2 decades younger. The cardiac muscle did not know what the calendar said. It responded to the stimulus it was given. Now consider what the neurology system has assembled for your brain. Lecanemab, the most recently approved Alzheimer's therapy, costs $26,500 per year. It requires bi-weekly intravenous infusion in a clinical setting with trained infusion staff. It demands MRI monitoring at specified intervals to detect amyloid-related imaging abnormalities, brain swelling, and microhemorrhages that occur in approximately 21% of treated patients, with 3% experiencing symptoms severe enough to require dose interruption. The clinical trial evidence showed modest slowing of cognitive decline on specified assessment scales, with ongoing debate about the functional significance of the measured difference. Lecanemab does not raise your BDNF. It does not increase neurogenesis in your dentate gyrus. It does not grow your hippocampus. It does not activate the natural killer cells that constitute your cancer immunosurveillance. It does not reverse your cardiac aging. It manages one molecular pathway, amyloid clearance, in a disease whose pathology involves that pathway among many others. Your body's version of neuroprotection, 3.5 accumulated minutes of vigorous activity per day, producing BDNF, growing hippocampal tissue, activating cancer-protective immune surveillance, triggering cardiac adaptation, simultaneously through interconnected biological cascades, at zero cost, with no monitoring requirements, no infusion schedule, no side effect profile. BDNF cannot be administered as a drug. This is not a current limitation of pharmaceutical technology awaiting solution. The protein does not cross the blood-brain barrier when delivered externally. The delivery mechanism is biological, and the biology requires the internal production that vigorous exercise triggers. No external formulation replicates it. The pharmacology is unambiguous, and the neurologists who work with it know it. The most expensive neurology clinic in the world cannot give your brain what 10 minutes of genuine effort gives it for free. The mortality ratios: 4-to-1 for all-cause mortality, 8-to-1 for cardiovascular death, 10-to-1 for diabetes, come from directly measured accelerometer data tracking real deaths in large, well-characterized populations. The methodology represents a categorical improvement over the questionnaire studies it replaces. This is strong evidence. The ratios should be held with confidence. The 3.5-minute cancer finding, a 40% risk reduction in women from daily accumulated vigorous activity, comes from the same accelerometer methodology applied to cancer outcomes. The data is real. The precise molecular mechanism connecting brief vigorous bursts to cancer outcomes is directionally understood through the natural killer cell, myokine, and DNA repair pathways described above. The complete mechanistic map at molecular resolution has not yet been published. The association is strong. The full mechanism is directionally supported, not yet fully mapped. The BDNF exercise connection is extensively replicated across multiple laboratories, multiple populations, multiple methodologies. The mechanism is understood from muscle production through blood-brain barrier crossing to hippocampal TrkB receptor binding and neurogenesis induction. This is strong evidence at both the associative and mechanistic level. Maguire's taxi driver hippocampal findings are published, peer-reviewed, replicated in subsequent studies, and structurally confirmed by MRI. The hippocampal growth finding is strong. The directional connection to Alzheimer's risk reduction is supported by what is known about cognitive reserve, the buffer built by structural brain growth against the neurological losses of aging. It is not yet established with the statistical power of a dedicated longitudinal, randomized trial. The cardiac aging reversal 20 years in 5 hours per week exercisers, including high-intensity interval training, is a specific published finding from Levine's group, directionally consistent with everything known about cardiac adaptation, and not yet a consensus-level claim generalizable across all populations and starting fitness levels. Strong claims are strong. Promising claims are promising. They are not the same category. The distinction matters because your trust in the strong claims should not be weakened by overreach on the promising ones. This is not a recommendation to stop walking. Your 30-minute morning walk is real movement producing real metabolic benefit. It is vascular protection, joint lubrication, lymphatic flow, mood regulation through endorphin and serotonin signaling. It is not nothing. Continue. What the accelerometer data requires you to add is gear shifts, brief, real, intentional crossings of the vigorous threshold, moments where your breathing becomes the limiting factor. These do not require a gym membership. They do not require 30 consecutive minutes. They require intensity. 3.5 minutes is the floor the cancer data identified. It is the daily accumulation sufficient to move the mortality needle in the specific outcome most feared and least understood. More produces more. The dose-response relationship continues above 3.5 minutes. The 3.5 minutes is the evidence-supported minimum that the questionnaire could not count for 30 years. The accelerometer counts everything: taking your stairs fast instead of the elevator, jogging to the end of your street and back, cycling hard for 90 seconds, playing chase with your grandchild or your dog until speech fragments, carrying groceries up a flight of stairs quickly, swimming 2 laps at genuine pace. These are not warm-ups. These are the intervention. Your biology responds to the gear shift regardless of context. The muscle fiber recruitment does not know whether it is occurring on a treadmill or a car park. The BDNF release does not distinguish a gym from a stairwell. The natural killer cell deployment does not require specialized equipment. The adaptive signal does not care what you call the activity that triggered it. It cares about the threshold. Cross it. Briefly, daily, in whatever form Tuesday offers. You now know that 3.5 minutes is not an arbitrary number. It came from an accelerometer, not a questionnaire. It was invisible to 30 years of exercise science, not because the science was wrong, but because the instrument measuring the science could not see it. It captures the accumulated gear shifts of an ordinary moving day. The sprint for the bus, the fast stair climb, the breathless minutes of playing chase. You know what happens inside your body during those minutes. Your type 2 muscle fibers recruit, the ones that have never fired during your morning walk. Your muscles manufacture BDNF and release it into your bloodstream. It crosses your blood-brain barrier. Your hippocampus receives the molecular signal for growth. Your natural killer cells mobilize for cancer immunosurveillance. Your heat shock proteins surge. Your DNA repair machinery upregulates in response to the mild oxidative stress the intensity created. You know that the clarity after something physically hard is not a mood. It is BDNF inside your skull, measurable. It was always happening. You were not given its name until now. You know your walk is real, and you know it is not enough. You know the guidelines were built on memory. The accelerometer built them on measurement. The difference between those two instruments is the difference between 30 years of invisible protection and the science that can finally see it. The gear shift takes 30 seconds to initiate. Your heart responds within 90 seconds. Your brain receives BDNF within 4 minutes. Your cancer biology changes across weeks of accumulated minutes. Your hippocampus responds across months of consistent threshold crossings. 3.5 minutes, not because it is easy, because it is the minimum the data identified. Because your biology does not require a structured session, it requires a threshold. Because the questionnaire could not count the moments your body was already using. And now you can. The gear was always there. Now you know what it does when you use it.